guys, we're going to do Unit 8, Lesson 6, and this is solving equation using identities. So, this can be kind of tricky, but just hang in there and you will be A-okay. So, today we're going to concentrate on the double angle formulas. The double angle formulas are located in your reference sheet, so these are not something that you need to memorize. This one, however, is one that you have to memorize. And if you remember, that's a Pythagorean identity. So what I want to do right now is I just kind of want to manipulate this one. You can write it a couple different ways. If I wanted to find the value of sine squared A, I could move the cosine squared A to the other side and I would get this value. And likewise, if I wanted to solve this equation for sine squared A, I would get 1 minus sine squared A. So those are just alterations of that Pythagorean identity, and it is important to be able to notice those. Okay. Solve the equation sine 2a minus cosine of a equals 0 for all values of a on the interval when a can be in between 0 and 360 degrees. So the first thing I want to do is I want to take knowledge of this, sine of 2a. So when you're solving these, if you see a double angle, like sine of 2a, cosine of 2a, you automatically want to flip to your reference sheet and say, all right, how can I rewrite the sine of 2a? I can rewrite the sine of a, and again, there's only one value, first the sine of 2a, cosine of a. Cosine of 2a has two different ones. We'll talk about that later. So I'm going to replace sine of 2a as 2 sine a cosine a minus cosine a equals 0. So now I'm looking at this and I'm going to say, oh, okay, well, what do both of these terms have? Well, they both have a value. They both have cosine of a in their term. So I'm just going to factor out a cosine of a. Okay, so now that this is in factored form, I'm going to set each factor equal to 0. All right, so if you remember, how do you solve for an angle measurement when it's written like this? Well, if you didn't remember where the cosine of A is equal to 0, you could turn on your graphing calculator and you could hit second cosine of 0 and we get 90. So I'm going to say A has a value of 90 degrees. I also want to point out, right, remember that unit circle? Very, very important. So I'm just going to quickly label this, and this is something that should be memorized. And if you remember, every coordinate is is cosine, comma, sine, right? So here's my 0, 90 degrees, 180 degrees, 270 degrees. So it's saying, when is the cosine equal to 0? Well, since cosine is the x value, the cosine has a value of 0 right here at 90 degrees, and at 270 degrees. I know that I needed to check that because they told me on this interval, right? So from 0 to 360 degrees, I want to know all the locations that the cosine is equal to 0. So far I have two answers for this. Now I'm going to solve this side. So 2 sine of A, add 1 to both sides, divide by 2. Sine of A equals 1/2. All right, well, this one's a little bit trickier because I don't have 1/2 on one of those, one of these coordinates that I marked off. So again, if you need some help, you don't remember the value when sine is at what angle measurement for sine has a value of 1/2, open your calculator. You're going to hit second sine of 1 divided by 2, or 0.5. And you get 30. So far, we are at 30 degrees. Well, let's talk about this. So we know that this is a positive measurement. We know that the sine is positive in quadrant 1 and quadrant 2. So if I was to draw a 30-degree angle, right, that would be right there. And if you remember from your 30, 60, 90 reference triangle, opposite hypotenuse would be 1/2. Well, I know that there's another reference triangle that I could draw with a reference angle of 30 degrees. Right, this would be 1/2. Well, how many degrees did I have to travel in order to get a reference angle of 30 degrees in the second quadrant? Well, I had to go 90 degrees Sorry about that. Got so excited here. My page is jumping all over the place. I had to go 90 degrees plus, well, let's see. If this bottom angle here is 30, that means this angle here is 60. I had to go an additional 60 degrees for 150 degrees. So the answer to this question is, it says solve for all values of A. If A has a value of, and I'm going to go in numeric order, 30 degrees, 90 degrees, 150 degrees, or 270 degrees. When I substitute those values into this equation, I will get 0 equals 0. Okay, pause the video, rewind it if you need to take a look at that again. Okay, exercise 2. Solve the equation cosine 2a plus 5 cosine a plus 3 equals 0 for all values of a on that same interval of 0 to 360. Well, if you noticed before, cosine of 2a has two possible values. It could equal 2 cosine squared a minus 1, or it could equal 1 minus 2 sine squared of a. Since this equation already has a cosine in it, I am going to choose to use, when I substitute the cosine of 2a, right, I'm going to replace the cosine of a with the identity 2 cosine squared a minus 1 plus, and I chose to use the cosines because there was already a cosine in this equation, and I don't want to confuse myself. I don't want to have a bunch of cosines and sines. I want to be consistent. I want all cosines or all sines, if possible. So now that I replace cosine of 2a with its identity, with its double angle, I'm going to continue writing what was left in the equation. And this looks kind of messy, right? So let's see, what can I do here? I'm going to combine some like terms. So I have 2 cosine squared a. I have a minus 1 and a plus 3, so I'm going to take care of that. That gives me plus 2. All right, this still looks kind of messy to me. It looks confusing. I shouldn't say confusing. It just looks like there's a lot of stuff in there. So I'm going to use the substitution of u. And all I'm going to do is I'm going to say, wherever I see a cosine of a, I'm going to replace it with a u. All right, let's see what happens. So 2, instead of cosine of a, I'm going to use a u, but it's being squared, plus 5. Instead of cosine of a, I'm going to use u, plus 2. Now this is something that I know I can factor, right? It doesn't look like all crazy with all these cosines and cosine squareds. It looks like something that I can factor. And if you remember, this is one of those harder trinomials to factor. So I have to multiply to the ends. So I'd have to find two numbers that multiply to 4, but at the same time add to 5. And those values are, multiply to 4 would be 4 times 1. 4 plus 1 is 5. Now, since there's 4 terms, I'm going to factor it by grouping. So first, I'm going to group these guys. Make sure I get my highlighter. Group these guys together. They have a common factor of, and that's not a negative. Sorry about that. These guys are getting grouped together, and they are both divisible by 2u, leaving me with u plus. Then I look at the next one. I have a 1u plus 2. Their only common factor is a 1. I know I factored by grouping correctly because I have the u plus 2. And then I can put the u plus 1 in a parenthesis. But now I have to remember, u doesn't mean u. U means what? Cosine of a. So I'm going to continue that work up here. So really, and I'm going to set each factor equal to 0 in the same step. So I'm going to replace u with cosine of a and set each factor equal to 0 in the same step. So I'm going to have cosine of a plus 2 equals 0, and not u, but cosine of a plus 1 equals 0. All right, so let's solve. So I have cosine of a minus 2 to the other side. Well, if you go to your graphing calculator, and you say, all right, I have to turn this into a degree measurement. Second cosine of negative 2. What happens? You get an error message, which is correct. You should get an error message. So this is an error, so we omit this one. This one, we have 2 cosine of a equals minus 1 to both sides. Divide by 2. cosine of A equals negative 1/2. All right, so if you don't remember where the cosine is equal to negative 1/2, you help yourself out by saying second. Oh, let me clear that. Second cosine negative 1 divided by 2. Okay, so A has a value of 120 degrees. So I'm going to draw myself my reference, right? So I know the cosine has a negative value in quadrant 2 and quadrant 3. Cosine of 120, so let's see. What kind of reference angle would that be? If this is 120 degrees, right? So here's 90. I went 30 degrees past 90. So that means my reference angle here is 60 degrees. And you're saying, why do I need to know that? Well, because let's see. The cosine of 60 is negative 1 over 2. So now I need to figure out where else would I have a negative cosine value and a reference angle of 60 degrees. Well, that would be right here in this quadrant, right? So what would this reference angle be? So I start at 0, right, and I go all the way around here. Well, how would I figure out that value? Well, this value right here is 180 degrees, right? I went 60 degrees past that value. So if I add these guys up, 180 plus 60 is 240 degrees. So the answer to this question is, if A is equal to 120 degrees and 240 degrees, it will solve this equation. So again, these are these kind of problems where you might have to pause this video and go back, re-listen to it, and try to redo it. Let's see. So solve the equation cosine squared x plus 4 sine x plus 4 equals 0 for all values of x on this interval. Ooh, okay, so I don't see any double angles. I don't see any cosines of 2x or sine of 2x. I do, however, see this part, this cosine squared. So I'm just going to jot down a couple things up here that I remember. So I know sine squared x plus cosine squared x equals 1. Well, I also remembered before that if possible, I want my equation to either have all sines or all cosines. So I can rewrite cosine squared x. So if I solve this Pythagorean identity for the cosine squared of x, I get cosine squared x equals 1 minus sine squared x. So I'm going to replace that highlighted cosine of 2x with 1 minus sine squared x. All right. Now I'm going to keep writing plus 4 sine of x plus 4. I'm going to tidy up this equation and I'm going to see what I can combine. So this 1 and that 4 can combine. So I have negative sine squared x plus 4 sine x plus 5 equals 0. And if you notice, I'm going to go ahead and use my u again. I'm going to say u stands for sine of x. So wherever I see a sine of x, I'm going to replace it with a u. So this is going to be a negative u squared plus 4u plus 5 equals 0. And now since this is a quadratic, I'm happy it's equal to 0. But when you're solving these, your quadratic term, in this case, which would be the u squared, has to have a value of a positive. So I'm going to go ahead through and multiply through by a negative 1. Right, so then that turns my quadratic term into a positive. I know how to factor something that looks like this. Right, multiplies to 5 adds up to negative 4. Well, that's going to be negative 5 and 1. Then I'm going to remember that u doesn't mean u means sine of x, and then at the same time I'm going to set each factor equal to 0. So replace u with sine of x minus 5 equals 0, sine x plus 1 equals 0. Solve here, so I have sine x equals 5, sine x equals negative 1. Well, if you evaluate second sine of 5 in your graphing calculator, you get an error message, so that's out. Sine of x equals negative 1. So again, I'm going to refer you back to this thing, right? So it'd be one thing to memorize maybe as soon as you start taking the Regents exam. You write this down. Remember, it's always cosine, comma, sine. All right, so I want to know when the sine has a value of -1. Well, I'm looking at my y, so it's 0, 1, 0, -1. So that would be right here. I know this is 270 degrees. So in this case, there was only one answer because the sine is only equal to -1 at one location on this interval. Okay, so that answer was 270 degrees. All right, solve the equation 3 cosine of 2 theta equals 2 for all values of theta on the interval between 0 and 360. Express all answers to the nearest tenth of a degree. Note that there are multiple ways to solve this problem. All right, so a couple of things before we start. This part, to the nearest tenth of a degree, tells me it's not going to turn out that nice, which is okay, but we always stress when we get decimals for some reason, but don't stress it. Now I want to pay attention to something else. Am I going to use a Pythagorean identity or am I going to use a double identity? A double angle identity. Well, if you said double angle identity, you are correct. So let's see. And cosine of 2 theta, remember the cosine, the double angles for cosine, there's two different options. I'm going to choose to use this one. And remember, I found this on my reference sheet. Okay, I'm going to go ahead and distribute. Now that I notice that there's a squared in here, I'm going to force it equal to 0. So when I move that, oh, look at me, I didn't distribute correctly. I'm going to -2 to both sides, so that gives me a -5. Again, this looks crazy to me, so I'm going to go ahead and use my u. So I'm going to say u equals the cosine of theta. So now I have 6u squared minus 5 equals 0. All right, I'm going to go ahead and continue to solve for u. So I'm going to move that 5, that -5 to the other side. Divide by 6. U squared equals 5 over 6. And if something's squared, you got to take the square root of both sides. So u equals plus or minus. Remember, when you take the square root of something, you have to put plus minus. Okay, so remember, u doesn't have a value of u. U really means cosine of theta. So cosine of theta could equal the positive square root of 5, 6. Or it could equal the negative square root of 5, 6. This is where I grab my calculator, right? Second cosine, second square root of 5 divided by 6. And I get 24.09. The question said to the nearest tenth, so I'm going to say this value of theta is 24.1 degrees. So cosine, again, it's a positive value, right? So let's quickly do new. So okay, so if I had this and this was 24.1 degrees, right? And I drew a reference triangle in there. Where else would cosine be positive? Good, if you said this quadrant. Well, how would I get a 24.1 degree reference angle down here? Well, I'm going to use the knowledge that this is 360 degrees. If I subtract 24.1 from that, I get a value of 335.9. So the cosine at 24.1 and at 335.9 degrees will solve this equation. Now we got to look at the other value we obtained. So I come back to my calculator, second cosine of negative second square root 5 divided by 6. And we get 155.905. So I'm going to say, go back to green. Theta equals 155.9 degrees. All right, so we know that there is another possibility. Okay, so draw another. So 155.9 is about right here somewhere. So why did it end up in the second quadrant? That's so interesting because cosine is negative in the second quadrant. Oh, that makes sense because I was looking for a negative value. So 155.9 is right here. Well, I know that cosine is negative in this quadrant and in this quadrant. Well, the reference angle for this area right here would be, well, if this is 180, 180 minus 155.9, my reference angle right here would be 24.1 degrees. Okay, so if I had to draw, so that would be the triangle. How would I get a 24.1 degree down here? Well, if you said 180 plus 24.1 degrees, you are absolutely correct. 180 plus 24.1 would be 204.1 degrees. Now again, as I keep saying, you might have to pause the video, go back and rewind it, especially for this end part here when we're finding the 2-degree measurements. I would encourage you, even if you're not really understanding the parts that I did in red here, really solve it up, do all the green parts, because that'll get you partial credit. And these are usually the questions that are in part 2, 3, or 4, mostly the later questions. So there's lots of room for partial credit. And the last one. Show that the trigonometric equation cosine of 2 alpha plus 3 sine squared of alpha minus 6 sine alpha plus 7 does not have any solutions. Okay, so let's figure this out. I have a double angle here. Well, in this double angle, I have sine and sine. So I want to use the cosine, the double angle for let me stop. I want to find the cosine, the double angle formula for cosine that involves sine. So that would be 1 minus 2 sine squared, this crazy looking alpha thing. And then I continue writing. All right, so let's see. What can I combine here? I can combine my negative 2 sine of alpha plus 3 sine squared of alpha, right? Because they're both sine squareds alphas. And I get sine squared alpha. My minus 6 sine of alpha is going to stay because there are no other sine of alphas. And that positive 1 and that 7 can get combined to be 8. Again, I'm going to use my u. I'm going to say u stands for sine of alpha. So now I have, instead of sine, I have u squared minus 6u plus 8 equals 0. I know how to factor this. This is going to be u. I like to call it a double bubble. Let's see. This one's going to have to be a minus, right? Negative times a negative is a positive. 4 and 2. Remember that u is not u. U is really sine of alpha. Minus 4 equals 0. Sine of alpha minus 2 equals 0. So solve these. Sine alpha equals 4. Sine alpha equals 2. Let's see, let's go to my calculator and write does not have any solutions. So second sine of 4, what happens? Oh, I get an error. Good. So I solved it. That's not a solution. And then I hit second sine of 2. Also get an error message. So since they were both errors, we effectively proved that it does not have any solutions. All right, so let's recap. We studied, what did we study this time? We used the Pythagorean identity, sine squared theta plus cosine squared theta equals 1. Sometimes we had to manipulate that into sine squared alpha or cosine squared alpha. That one is not on your reference sheet, so that is one that you have to memorize and remember that you can manipulate it. These guys here, these double angle formulas, are on your reference sheet. Sine of 2a only has one value, which makes it easier. But remember, if you're working with cosine, you want to make sure that your equation is consistent. So if your equation has a sign in it already, you want to use this one. If your equation doesn't have any value, any other signs in it, then you want to keep consistent. You want to make sure it's all sines, all cosines. And then just remember that sometimes you have to make sure that you have to look at your interval. So this was between 0 and 360. So sometimes there are more than one ways to get that reference angle that we were looking for. All right, thanks for tuning in, and we'll see you in class tomorrow.